Welcome to our deep dive into the vast and mysterious world beneath the ocean's surface. The ocean covers more than 70% of our planet, yet it remains one of the least explored and understood ecosystems on Earth. It's a world filled with stunning beauty and profound mysteries, where the depths hold secrets about the history of our planet, the limits of biological life, and clues to our climate system. Today, we're embarking on a thrilling journey to discover just how deep the sea is. We'll explore the various layers of the ocean, from the sunlit upper levels where life abounds, down to the darkest depths of the hadal zones, where the pressure is immense and light is non-existent. Along the way, we'll encounter exotic creatures, investigate historic and modern explorations, and even uncover some of the ocean's most intriguing secrets. Join me as we descend through layers of water, pressure, and darkness to answer the age-old question, how deep is the sea? This exploration is not just about reaching the bottom, it's about understanding the different environments and the incredible life forms that thrive under conditions unimaginable to those of us on land. Let's dive in! The ocean layers. A descent into the deep. Sunlit zone, 0 to 200 meters. Welcome to the vibrant and bustling world of the sunlit zone, where sunlight bathes the ocean and supports a rich diversity of life. Here, the waters teem with some of the ocean's most beloved species, such as playful dolphins and majestic whales. Vibrant coral reefs, which house countless species of fish and invertebrates, offer dazzling displays of color and form. This zone is also crucial for marine photosynthesis, which not only supports ocean life but also plays a key role in absorbing carbon dioxide and producing oxygen, making it vital for life on Earth. Twilight zone, 200 to 1,000 meters. As we descend deeper into the twilight zone, the light begins to fade, transitioning the environment into a dimly lit world where conditions drastically change. In this zone, light is scarce, and the pressure starts to increase significantly, creating a challenging environment for the creatures that call it home. Here, many organisms exhibit bioluminescence, a magical glow produced by chemical reactions within their bodies. This eerie light is not just for show, it's used for attracting prey, communication, and defense against predators. Creatures such as jellyfish, certain types of squid, and deep-sea fish with glowing lures wander these shadowy waters. Midnight zone, 1,000 to 4,000 meters. Delving further into the midnight zone, we enter a realm of complete darkness where the sun's rays never penetrate. Here, life exists in one of the most extreme settings on Earth. The pressure is crushing and the temperature drops near freezing. Despite these harsh conditions, life endures. Unique species like the mysterious anglerfish, with its iconic bioluminescent lure, and the elusive giant squid thrive in the darkness. These creatures have adapted remarkably to the absence of light and the immense pressure, developing enhanced senses and special physiological traits to survive. Abyssal zone, 4,000 to 6,000 meters. Beneath the midnight zone lies the abyssal zone, where the seafloor spreads vast and deep. This zone is marked by extraordinary high pressure, frigid temperatures, and total darkness. Life here is sparse compared to the bustling activity of the shallower waters, but it is no less remarkable. Organisms like the sea cucumber, certain species of bristleworms, and unique forms of life that rely on chemosynthesis rather than photosynthesis to obtain energy inhabit this zone. These creatures are often gelatinous with minimal skeletal structure to withstand the extreme pressure. Hadal zone, 6,000 meters to the deepest parts of the ocean. The final frontier of our oceanic descent brings us to the Hadal zone, named after Hades, the underworld of Greek mythology, and it is just as mysterious. This zone includes the ocean's deepest parts, such as the Mariana Trench, which reaches depths of nearly 11,000 meters. The conditions here are among the most extreme on the planet, with crushing pressures over 1,000 times that of the surface. Exploring this zone requires highly specialized technology, like deep-diving submersibles equipped with reinforced structures to withstand the immense pressures. Despite the challenges, life finds a way. Certain species of foraminifera, small, single-celled organisms, and even some types of fish have been found at these incredible depths. Each of these layers tells a unique story of adaptation and survival, painting a complex portrait of life in the ocean's depths. As we explore these layers, we not only uncover more about our planet, but also about the resilience and adaptability of life itself. Human interaction and exploration. The history of deep-sea exploration is as deep and varied as the ocean itself. Initially, human knowledge about the ocean depths was limited to what could be seen from the surface or what washed ashore. However, the 19th century marked the beginning of a more scientific approach to exploring the ocean. The British HMS Challenger expedition, 1872-1876, was a pivotal moment, often considered the birth of oceanography. This expedition traveled nearly 70,000 nautical miles, mapping the ocean floor and discovering over 4,000 new marine species, setting the stage for future exploration. Today, exploration of the deep sea is propelled by sophisticated technology. Submersibles and remotely operated vehicles, ROVs, have become essential tools in the oceanographer's kit. Submersibles like Alvin, which was first launched in the 1960s, can take humans deep beneath the ocean's surface, allowing for direct observation and collection of samples from the ocean floor. On the other hand, ROVs, which are unmanned and operated remotely from a ship, can descend to even greater depths and stay underwater for longer durations without the risks associated with human passengers. These technologies provide critical insights into the biological, chemical, and physical properties of deep-sea environments. Record-setting dives. Among the most notable achievements in deep-sea exploration was the dive by filmmaker and explorer James Cameron in 2012. Cameron's solo journey to the Challenger Deep, the deepest known point of the ocean located in the Mariana Trench, was a landmark event. He descended to a depth of nearly 11,000 meters, 36,000 feet, in the deep-sea Challenger, a submersible he helped design. This expedition not only pushed the boundaries of human exploration, but also brought back valuable data and samples for scientific research. Cameron's dive underscored the potential for human ingenuity to overcome the challenges of deep-sea exploration and increased public interest and support for understanding these mysterious depths. Through these methods and monumental efforts, humans continue to unravel the mysteries of the deep sea, each expedition bringing us closer to understanding the vast, unexplored waters of our planet. Physical challenges of deep-sea exploration. Exploring the deep sea presents a series of daunting physical challenges that push the limits of both human and technological capabilities. The environment deep below the ocean surface is hostile and unforgiving, characterized by extreme conditions that must be carefully managed to conduct safe and effective exploration. One of the most significant challenges is the extreme pressure. As you descend every 10 meters below the surface, the pressure increases by approximately 1 atmosphere. At the deepest points of the ocean, such as the Challenger Deep, pressures exceed 1,000 atmospheres, equivalent to the weight of an elephant balanced on a postage stamp. These immense pressures can crush conventional submarines and deform the strongest materials used in surface-level machinery. The temperatures in deep-sea environments also pose a serious challenge. The further one descends, the colder the surroundings become, typically falling to just above freezing in the deep ocean. This chilling environment can cause materials to become brittle and electronics to fail, complicating the operation of submersibles and instruments. Technical challenges. Operating in such extreme conditions requires highly specialized equipment and technology. Submersibles must be constructed with materials capable of withstanding immense pressures without compromising their structural integrity. Moreover, the electronic systems used for navigation, data collection, and communication must be protected against the cold and pressure, often through the use of special housings and innovative engineering solutions. Effects on the human body and machinery. For human-crewed missions, the physical environment of the deep sea can have profound effects on the body. While modern submersibles protect their occupants from the direct impacts of pressure, the psychological stress of being in a small, confined space under such conditions can be significant. Additionally, the risk of decompression sickness, or the bends, is a critical concern during ascent, necessitating careful pressure management and gradual reacclimatization to surface conditions. For machinery, the deep sea is equally taxing. Hydraulic systems, battery packs, and propulsion mechanisms must all be designed to operate under high pressure and low temperatures. Furthermore, the remote nature of deep-sea environments challenges maintenance and repair, requiring that systems be extremely reliable and that redundancies be built into critical components. Despite these challenges, advancements in technology and our understanding of deep-sea conditions continue to improve, enabling deeper and longer-duration missions into the ocean's most remote regions. This ongoing progress not only enhances our capacity for exploration, but also increases our ability to monitor and protect the deep-sea environment, a crucial frontier in understanding our planet. The mysterious residents of the deep. Deep-sea environments, some of the most extreme habitats on Earth, are home to a diverse array of creatures with remarkable adaptations and behaviors that allow them to thrive under conditions utterly inhospitable to most forms of life. These residents of the deep sea have evolved in isolation, developing unique survival strategies and physical adaptations that continually astonish scientists and deepen our understanding of life's incredible versatility. In the deep sea's absence of light, many organisms have developed bioluminescence, For instance, the anglerfish uses a light-emitting appendage to attract prey, while the lanternfish emits light from its belly to break up its silhouette and evade predators. The vampire squid can eject bioluminescent fluid to confuse predators and escape threats. Moreover, gigantism is observed in species such as the giant tube worms found near hydrothermal vents, which can grow several meters long, and the colossal squid, which is the largest known invertebrate. These adaptations to scarce food resources allow creatures to process food more efficiently or survive long periods without eating. Physical adaptations in these creatures are profoundly influenced by the immense pressure and darkness of their environment. Many deep-sea species lack air-filled cavities like swim bladders, which are common in shallower water fish, to avoid being crushed by pressure. Their bodies are often soft and pliable, which helps in surviving the great pressure. Coloration in these depths tends to fade, with many creatures showing transparent red or black bodies. Red appears black at depth and provides perfect camouflage from predators. Interesting. Behaviors and survival strategies. Deep-sea creatures have also evolved intriguing behaviors to cope with the darkness, cold, and high pressure. For example, the gulper eel has an enormous mouth that allows it to swallow prey much larger than itself, a useful adaptation given the rarity of food. Many deep-sea fish are ambush predators, like the cookie-cutter shark, which uses suction to attach itself to larger fish and marine mammals, excising chunks of flesh with its specialized teeth. Reproductive strategies are also uniquely adapted to ensure the maximum survival of offspring in this sparse environment. The deep-sea hatchetfish, for instance, uses bioluminescence to attract mates, a crucial ability in the vast darkness. Many deep-sea organisms, such as the brooding octopus, guard their eggs against predators and the harsh environmental conditions until they hatch. Others, like the sea cucumber, disperse thousands of eggs into the water to increase the chances that some will survive. The extraordinary adaptations and behaviors of deep-sea creatures provide crucial insights into how life can thrive under some of the Earth's most extreme conditions. These fascinating biological phenomena not only help us understand the biodiversity and ecological dynamics of deep-sea environments, but also enhance our broader knowledge of biological resilience and adaptability, informing fields from evolutionary biology to astrobiology and beyond. This ongoing exploration of deep-sea life continues to reveal not just new species, but also unexpected ways that life adapts to the most challenging environments imaginable. Fascinating finds in the deep sea. The deep sea remains one of the last unexplored frontiers on Earth, harboring both historical relics and biological novelties that enhance our understanding of the world. Among the most captivating discoveries are numerous sunken shipwrecks, such as the RMS Titanic, which lies about 3,800 meters below the surface. Its discovery in 1985 provided not only invaluable historical insights, but also a stark reminder of the tragedies that have occurred at sea. Similarly, ancient shipwrecks like the Antikythera wreck off the coast of Greece have yielded artifacts like the Antikythera mechanism, an ancient astronomical calculator that astonishes with its sophistication. Beyond historical artifacts, the deep sea is a hotspot for biological discoveries. Remarkable species such as the snailfish, which thrives at depths exceeding 8,000 meters, challenge our understanding of survival under extreme pressure and cold. Hydrothermal vents, often found in these deep regions, host vibrant ecosystems centered around chemosynthetic bacteria, which convert chemicals from the vent fluids into energy. These vents support unique communities, including giant tube worms, which can grow up to 2 meters long, and eyeless shrimp, which rely on symbiotic relationships with bacteria for nutrition. These finds underscore the deep sea's role as a repository of both historical and natural treasures, emphasizing the need to understand and protect this mysterious and critical part of our planet. Each discovery is a piece of the puzzle in our ongoing quest to understand the complexities of life and history on Earth. Environmental concerns and the deep sea. The deep sea is not immune to the impacts of human activities, which pose significant threats to its complex and poorly understood ecosystems. Deep sea mining, aimed at extracting minerals and metals from the seabed, is particularly concerning. This process can disrupt the seafloor habitat, releasing plumes of sediment that smother marine life and spread toxins. Additionally, pollution, including plastic debris, chemical runoffs, and oil spills, reaches even the most remote deep-sea environments, affecting the health and reproductive capabilities of marine life. Conservation efforts and international laws, protecting deep-sea environments. In response to these threats, several conservation efforts and international laws have been implemented. The United Nations Convention on the Law of the Sea, UNCLOS, serves as a regulatory framework for marine environmental protection, including the deep sea. Organizations like the Deep Sea Conservation Coalition advocate for responsible management of ocean floor resources and work to raise awareness about the ecological importance of the deep sea. Protected marine areas are being expanded to include deep-sea habitats, although enforcing these protections in remote areas remains challenging. As we surface from the depths of our ocean exploration, we're left with a profound appreciation for the deep sea's diverse and complex ecosystems. From vibrant coral reefs to the enigmatic creatures of the hadal zone, each layer has unveiled unique life forms and remarkable adaptations. Our journey highlighted not only these wonders, but also the impact of human activities, emphasizing the need for careful stewardship and continued scientific inquiry. With each descent, we uncover more about our planet's hidden depths, revealing shipwrecks, new species, and unexpected ecosystems around hydrothermal vents. These discoveries underline the importance of protecting these critical habitats. As we continue to explore, let's commit to safeguarding the ocean's vast mysteries and the life it sustains. Keep exploring, keep wondering, and join us as we strive to understand and preserve the unfathomable depths of our blue planet.